Hello. The purpose of this video is to go through the potential use cases for EMAC or Enhanced MAC Address VLANs. So the primary use case for an EMAC is a situation where you may only have a single link to a service provider, but for example you've been given a /24 or some other broader subnet, broader than a /30, and you wish to make use of the extra addresses and assign them to different VDOMs, downstream VDOMs. So in this case here, we have the primary IP address assigned to the primary link here within the root VDOM, which then goes northbound to the service provider switch or router. Then southbound of that, I've got VDOMs A and VDOMs B. And you can see here that I have hosts assigned to the same subnet. So the primary is .1, .2, and .3. Now, clearly we wouldn't be able to do that in a normal situation on a single link, because that link would only have a single MAC address. So what the enhanced MAC does is it creates a pseudo MAC address for each subtended EMAC link. Okay, so you can, obviously these MAC addresses are bogus. I've just made them up for the purposes of the video. But you can see, for example, this one starts 00, this one 01, and this one 02. So that clearly differentiates them from each other. And it also means that any device northbound coming from upstream here, be that the internet or otherwise, that does an ARP request for .2 or .3 is going to get a response from these individual MAC addresses. And that traffic will be passed through this link along the virtual link to each individual VDOM. Now, another potential use case is if we shrink that down and we look at how we could possibly use that internally within the FortiGate, whereby perhaps we either want to share traffic between VDOMs, or maybe these VDOMs are VRFs. One of the defining requirements for an EMAC is that there is a primary interface first, and then the subtended or the secondary EMACs hang off that primary. So in this case, I'm going to use the NPU, the Network Processing Unit, which is one of two interfaces. And now they're not virtual, they are actually physical, albeit they're internal to the FortiGate. Here I'm using VLink 0 for this example, and I'm using .1 on VLink 0, and then whilst VLink 0 is in a VDOM, it can be any VDOM, it doesn't have to be the root. I'm then using .1 and .2. They get their individual MAC addresses just like the previous example, but they are then assigned internally within the FortiGate to the downstream VDOMs. Now, I haven't given names here because the names are largely irrelevant. The simple fact is that we have 3 VDOMs and they're all sharing the same subnet. Now, what this also facilitates is the ability for east-west communication or any-to-any communication, as you might expect if, for example, you were using a switch, an internal switch, right? Because these EMACs can all communicate with each other as though this were a virtual switch. So the lab setup that I'm going to demonstrate is that, but on an expanded basis. So I've got a primary FortiGate, which is indicated by these 3 VDOMs here, all right? I've got my WAN VDOM, which obviously, as the name suggests, goes northbound to the outside world. Within here, I have got a secondary VDOM. Now, whilst I have these shown here as VDOMs, in actual fact, in this use case, they are actually VRFs within my secondary VDOM. All right, and you can see their client VDOM is broken down into VRF. So rather than assigning these EMACs to individual VDOMs, I'm assigning them to individual VRFs within a common VDOM. But it's immaterial. The fact is the logic still remains. I've got my northbound interface here. The northbound interface owns the primary subnet and the primary MAC address. and then the subtended EMACs are then assigned to each individual VRF, where they have their own IP address and their own MAC address. Downstream of that, to show the transport of data, I have got a remote. This is a secondary FortiGate. And this FortiGate is linked to the primary FortiGate via a VLAN trunk. So these two individual red links here are actually a singular Ethernet link with VLAN tags. So it's a .1Q trunk, and I've got VLAN 10 going to VRF1, VLAN 20 going to VRF2, and then downstream within this remote FortiGate, I've also then broken it down into two VRFs, and I've put the VLAN sub-interfaces into VRF1 for VLAN 10, VRF2 for VLAN 20, and likewise northbound here, VLAN 20 goes into VRF2 on the upstream FortiGate, and VLAN 10 goes into VRF1 on this upstream FortiGate. Okay, let's have a look at this configuration now. So starting off with the core FortiGate, if I look at the interfaces here, I have got within my NPUs, just expand them here. So it's not the one, it's this one here. All right, so what I've got here is I've got within NPU VLink 0, I've got my core container, the hub of the EMACs, all right, here, and I have assigned this to the WAN VDOM, right? If I come back here again, expand those again, and then these two here are in VRF1 and in VRF2 in VLAN, in VDOM clients accordingly. Right. So if we go across here to the VDOM clients, here we can see that downstream, remember I've got a link to the downstream FortiGate, which I'm going to call the remote FortiGate. I've got VLAN trunks. See there, it's a VLAN, so this is a single interface broken down into sub-interfaces, VLAN 10 and VLAN 20. And then here I have these two EMAC links associated with this NPU link, which then communicate upstream to the WAN VDOM. So if we look at the routing table, get router info, routing table all, I have got here, firstly, a static route from each one of these VRFs pointing to the WAN VDOM, because that's going to be their gateway of last resort, right? So when they want to get out to the wide area network, they're going to go via .1, which exists in the WAN VDOM. Then I have the connected VLANs, which are the VLAN 10. Ignore this 12 for now. And then I've got their own IP address. So this is going downstream to the remote device, and you can see there, so that's the VLAN 10. This is VRF2, also going down to the remote device via that VLAN trunk. Notice that both these VRFs have got the same subnet. Right? Remember, because this one is 253.2, this one is 253.3, and then these are loopback addresses, 10.0, all right? So if I look at the static routes here, you can see I've got a simple static route saying to the outside world, go to 253.1, which is in the WAN VDOM. Okay, that should be self-explanatory. If I come to the WAN VDOM, here I have got going back to the individual VRFs, so .2, there's the loopback for .2, and here is VLAN 10 for the downstream device, also going via .2, and conversely, I've got the loopback of VRF2 in the client's VDOM going to 253.3, and VLAN 20 in the VRF2 of the client's VDOM going to 253.3. So notice I'm using the same subnet everywhere as though this were a switch, all right? So an internal switch where each device had interfaces on the same VLAN. So on the same switch rather. So if I open up here, I should be able to execute ping. So firstly, let me just show you here, diagnose IP list. Let's just do a pipe grep 192.168.253. Alright, so 253.1 is in the WAN VDOM, 2 and 3 are in the client's VDOM, but in their own VRFs. So from here, if I do an execute ping 192.168.253.2, okay, and .3, and I can ping those. Okay, so if I do a get router info routing table static, I've also got routes to these two, which are the loopbacks in those individual VRFs. So if I do an execute ping 10.0.1.1, I can ping that. So I'm now pinging the loopback in VRF1 in the client's VDOM and 2.1 as well. So I've got that hub and spoke communication from the WAN VDOM to both those downstream VRFs in the client's VDOM via this EMAC-VLAN environment. Now if I come to the remote site, remember the remote site is connecting, so this is a completely separate FortiGate. It is connecting to the upstream FortiGate via this VLAN trunk, right? So this is the corresponding here. So this is .1 and 10.1 and 20.1 on this side. And over here, if I come back to the client's VDOM, if I come to my interfaces, here I've got .2 of both of those subnets. So this is the interconnection between the core FortiGate and the downstream FortiGate. So again, if I come back here and I look at my routing tables here, you can see here that I've got a default route, in this case pinging to VRF1 on the core FortiGate and VRF2 via these individual sub-interfaces. So if I do a get router info routing table all, once again I have got my two VRFs separated on this side. So now if I do an execute ping dash options and I change my source here to 172.168.10.1 representing VRF1 here, and I do an execute ping 192.168.253.253.1, you can see that I'm now pinging all the way through the VRF on the core device, on the client's VDOM of the core device, and I'm going all the way to the .1 address which exists on the WAN, in the WAN VDOM of that core device. Okay, I do an execute ping 8.8.8.8. I can also get to the outside world, because if I come back here and I go to the WAN VDOM, I've got a policy here that says anything coming from any interface going anywhere, enable NAT. So I'm allowing, now I wouldn't recommend you use such a wildcard policy in day-to-day operation. I'm obviously just doing this for the purposes of the demonstration, but this policy allows east-west communication between the VRFs. It also provides north-south going to the egress. So if I look here, I have got an egress interface here in the WAN VDOM. So remember, this is my interface facing southbound to the client's VDOM and connecting to those VRFs. And this is my northbound interface reaching out to the internet. All right. So again, if I look at my static routes here, I've got a static route going out to 12.1, which is my internet connection. And then I've got these routes pointing back to this enhanced EMAC environment. All right. Likewise, if I come and I change the source to 20.1, which is the other VRF, all right, I can also ping 253.1. I can ping 253.2, and I can ping 253.3. So I can, from here, I can ping all the members, the hosts within the 253 range, because remember, they're all EMACs, and the EMACs are effectively hairpinning on the same interface to create a virtual switch type environment. And once again, I can get out to the outside world from this VRF because I'm going up to the WAN VDOM via that EMAC's interconnection, and I'm going out to the outside world because I've got routes allowing me to do so. So hopefully this made sense. Hopefully it gives you an idea in terms of how we can potentially use the EMACs to create a virtual switch type environment in the context. So let's just go back here to the global, go to the interfaces, and just from a reminder perspective, so here is my MPU. All right, so my MPU has got the primary EMAC, which exists in the WAN VDOM. Then I've got my secondary EMAC addresses, which are downstream in the client's VDOM, and each one has got its own host IP address, all within the same subnet. What you can't do, however, is have this route within the same VDOM as these. All right, so this is one cautionary tale here. If you do that and you create a any-to-any policy, you will end up in a broadcast storm type environment, like as though you had a looping environment on a normal Ethernet switch. So you don't want to do that. You want to have the clear separation of this root EMAC in a completely separate VDOM from any downstream ones. Right, so any questions regarding this video, please do not hesitate to reach out and we will answer them as expeditiously as possible. Thank you very much.